See me? Hello, everybody.
Hey, all
Hey,
right.
how you doing? Hi. Welcome to my office. What time is it? Is the time over there? Is it 7 o'clock? 6 o'clock
It's
your time?
6:01 here.
6:01. There you go. So I can always watch my clock behind me. Uh, is it right? Yeah, it's right there. So
Ah,
welcome. I
excellent.
did wear my Chicago Cubs hat just for y'all.
Oh,
They're
the
in.
Chicago Cubs. We're all White Sox fans.
Well, let me go get my White Sox hat real quick.
Wow, that's very diplomatic of you.
Anytime. Now I don't have a St. Louis hat, so I've got my limits.
Yeah, yeah.
Uh, there you go. All right, so welcome, my friends, to this exciting session on accelerated database recovery. It is one of my favorite newer features in SQL Server 2019. It's actually probably my favorite feature since Query Store, and I love Query Store. So accelerated database recovery is an excellent feature, probably a primary reason you would want to move to SQL Server 2019 if you're not there already, which you really should be because I believe 2016 is already out of support. So you should be moving to 2019 or to Azure. These features are in Azure as well, accelerated database recovery. But as Ross mentioned, if that is his real name, as Ross mentioned, click, there you go. My name is John Deardurff. You can just call me John because no one can pronounce my last name. I am a data and AI customer engineer, as he mentioned. There's the rest of the information. If you'd like to email me, feel free. If you have questions about accelerated database recovery after this session, feel free to email me. You can follow me on Twitter, follow my website, or on my GitHub, SQL MCT. I am the SQL Microsoft Certified Trainer. The materials that I have right here, the slides and my demo code is on my GitHub. It is my own code, so use at your own risk. It is my demonstration. It's not official Microsoft. I always have to do the legal disclaimer. Not official Microsoft code. It's my own demonstration. But it is, you can borrow it, use it in a test environment, development environment, if you want to play around with accelerated database recovery. It's a nice little demo to get comfortable with ADR. From now on, I'm just going to call it ADR. If you do like to know more about me or would like to know more about me, you can visit my website, sqlmct.com. I make no money off my website. I do no advertising at all, but you'll see a lot of code. Why is that up there? Get out of there, Mr. Presenting thing. Thank you. Always hovers over where I'm trying to look at. So I do have like writing SQL, performance tuning. In the future, I'll add more blog posts. I haven't done a blog post in a couple months. I've been busy. All right, so what does this session cover? Oh, we got Eric. Now we can get started. Now the awesome people are coming in. Not that the other people aren't awesome, but all right, so what does this session cover? Accelerated database recovery. We're going to start off, what is it? Yay, what is it? We'll look at the current database recovery process. What are our pain points that we have with accelerated database or prior to accelerated database recovery? What's the pain points that we run into? We'll look at the components. There's 4 core components that we have with accelerated database recovery. That we'll talk about those first so we can understand as we go through the ADR process what's happening in the background. That's going to take about 20 minutes to go through that material. The rest of the time is demonstration, where I'm going to show you how it works, and you'll be amazed at the magic. Specifically, short story short, short story shorter, I can recover from failure in less than 2 milliseconds. Did I say that incorrectly? No, it was. Let's say I was restoring a database and it takes me hours. If you've tried to restore a database, let me rephrase that. Recover a database, you restore the data, and then you have to go through the recovery process. Could take an hour, 2 hours. A lot of times it takes as long as your oldest active transaction. So I've seen customers, I've seen clients, I've seen friends. I have friends that play with SQL who their recovery time they're measuring in hours. I just mentioned milliseconds. You're cutting down your recovery time down to milliseconds. That is a true story. We'll see it in action. So if you're not excited yet, you will be. Okay, hopefully. So what is it? What is ADR? And from now on, I'm just going to say ADR, Accelerated Database Recovery. Otherwise, this session will be 4 hours long. So ADR is a new SQL Server 2019 engine feature. It's built into the engine. You really don't have to do much at all. Just turn it on and it's running. That greatly improves your database availability by completely redesigning the recovery process. So we'll look at what we've been using since 1998 and what we have now in 2019. 21 years difference between the design. That's always fun, right? So we'll look, it's a redesign of the recovery process. What are our benefits? Fast and consistent database recovery. I just mentioned fast milliseconds. We can recover our database and it's going to be consistent. It's still meeting our ACID properties of transactions: atomic, consistent, isolated, and durable. If you study transactions or work with transactions or transaction logs, we're having fast, super duper fast recovery. Instantaneous transaction rollback, where my rollbacks happen, I roll back a transaction in milliseconds, as opposed to if I had a bulk insert where I was inserting 10 million records. And as I was inserting those 10 million records, something bad happened. The power went out. Bob tripped over the power cable and turned off the server. That happens. That's why you don't let Bob in the server room. But something bad happens. You restart the server and we have to roll back all those transactions, undo all those transactions so we can leave our database in a consistent state. That could take hours and with our traditional format. Now we're talking milliseconds. A side benefit, two side benefits that just happen, is not the main purpose of accelerated database recovery. The main goal of recovery is to have those instantaneous recovery or to instantaneous rollback recovery. But some side benefits we also get: aggressive log truncation. Since I don't have to keep track of long-running transactions anymore, as we will see through the demonstration as we go through the process, I don't have to keep track of long-running transactions. I only have to keep track of what's happened since the last checkpoint, which means my transaction log can be aggressively truncated, which means my transaction log can be kept very small, under megabytes, under 1 gig, which means it's under 1 gig. It could be megabytes. We'll see in a demonstration. My log is going to be very small, which also means that's speeding up high availability, HADR, high availability disaster recovery. Because if we're doing that log shipping, I call it log shipping, where when high availability, you have the logs on server A, then replicate to server B, a lot smaller logs, a lot less to keep track of. So it improves that performance as well. And wait, there's more. It also reduces contention on your TempDB database. Wait, what? Yes, TempDB database. It affects your TempDB database. The TempDB database has row versioning for all your other databases on your instance. It also has all your table variables, temp tables, any temporary objects you're creating, row versioning. That's all being stored in the TempDB database. One of the side benefits of ADR, since basically we're using, not basically, we create a persistent version store that's using row versioning. Once I enable ADR, all that row versioning, snapshot isolation, temp tables, or what they're called, temp tables, temporary variables, they're now stored in your persistent version store, offloading that contention to from your TempDB. So it's improving performance in that area. So Those are your main benefits as we go through. This is why I get so excited about it, because it not only helps me with recovery, it's helping me out with a lot of other performance issues. A lot less log buffer flushes, a lot less of seeing right log wait times. If you're monitoring and you see a lot of right log wait types, those are, I'm not going to have those. I'm not going to have, well, I'm still going to have them. Sorry. But there's going to be less of them. So a lot of cool features. Now, another I don't know if this is a benefit or not. It is available in standard edition. I always think of anything that's available in standard edition as awesome. So you don't have to get enterprise edition for this awesome feature. All right. So hopefully I didn't oversell it, but let's look at how do I enable it? How do I turn it on? On Azure SQL Database, managed instances, it's on by default. And wow, that's difficult. Azure SQL VMs, you would have to enable it just like you would on premises. How do I enable it on premises? That code that's on the screen. Alter database, the name of your database, set accelerated database recovery equals on. That's all you have to do. And it's on, and your life is easier. Now, don't tell your boss, because then, you know, they'll say, what have you been doing all day? Oh, I've been dealing with these transaction logs. But it's that easy. It's just that one line. Now, there is an optional line where you see that their persisted version store file group equals a version store file group, whatever the file group you have. We'll see this in our demonstration. I set this up in the demonstration so we can see this in action. But when I turn on accelerated database recovery, it creates one of the components is the persisted version store. From now on, I'm just going to call it the PVS, persisted version store. This is the store, it's the magic. This is where the magic happens. This is keeping track of the row versioning of all my records. So that keeps a row version instead of having to deal with dealing with an individual record, dealing with locking. I now am using row versioning for my records. As we'll see that, I'll show you how to monitor that as well in the demonstration. If I don't specify where to put it, it will put that in the persistent version store in my primary file group with the rest of my database, my system objects, or the rest of my database. It might be a good practice to create a file group on a separate drive, maybe a SSD drive, a fast drive that is just used for the persistent version store. It'll offload the management of the row versioning away from the rest of your database. Not required, but it's another way I can improve performance by having the persistent version store in its own file group, in its own, on it, possibly its own drive. All right, so we will see that coming up. So, am I missing a? Oh, there's the slide I was looking for. I have my slides in the wrong order. Actually, do I want to do? Well, we'll do. Okay, I want to go back one. All right. So this is the current recovery process. What we've been using. I say 1998 since SQL Server 7.0. It could be in 6.5. Could have been before that. I started working with SQL 6.5 towards the end, but really 7.0. 1998. So, but this process has basically been the same, the recovery process since then. So 1998 to 2019, that's a mighty long time. It's almost 21 years. The technical term for this process is called ARIES, which stands for Algorithms for Recovery and Isolating Exploiting Semantics. I always have to remember that. I have to count it off my hand. What was it? Algorithms for recovering and isolating, exploiting semantics. I have no idea what that means. Those are five big words. I don't know what that means. Fortunately, I never have to say that again except for this demonstration. But this is the process that happens, our current process before ADR, before accelerated database recovery. Phase 1, 2, and 3. Phase 1 is still basically going to be the same. Again, we'll go through the new process here in just a moment. But the analysis phase just goes through and checks what's the current state of each transaction in the system at the time the SQL Server stopped. So power went out, whatever. Let's analyze. Let's look in the transaction log from the oldest dirty page. Dirty page is basically what was the oldest page that's in memory, or the buffer pool, buffer cache, page cache. One of my students this week was calling it page cache. Buffer cache, buffer pool. When you read data, your data pages are placed in that buffer pool. And they're the dirty pages until they're written back to disk. Or until the next checkpoint, and the checkpoint writes my dirty pages to disk. So the analysis phase goes through when I'm recovering from failure, or right after I restore a database and I need to recover. I first need to check what is the current activity in my transaction log since the last oldest dirty page, or since the last checkpoint. Analyze that data. It's going to analyze that data and compare logical sequence numbers between my data pages and the log entries in my transaction log. It'll compare those to analyze, do we need to redo or undo? Redo or undo? Once it analyzes that, I misspoke there. My Indiana accent kicks in sometimes. Once it analyzes that, then I will redo and then undo. Again, still current before accelerated database recovery. The redo phase will roll forward any transactions that were committed since the oldest uncommitted transaction. We'll roll those forward so they can be written to the database, so my database is in a consistent state. This actually runs fairly quickly. It is a small pain point, but it's not that big of an issue. I'm just replaying transactions, or replaying my DML statements, insert, update, deletes, create, alter, drops, for DDL statements as well. Rolling those forward. Once I get to that point, then my database is partially available. Technically, it's partially available, which means I possibly could still access some tables in the database, as long as I don't have to undo anything for those tables or records, where I still might need to place locks. Again, we won't get into locks or anything like that. Well, a little bit, maybe. But my database is partially available. That people could possibly access tables, but it's not really consistent on what people can access. When they say partially, most cases I've seen, people still can't get to the database at this point. Technically, that's possible, but in most cases, they're still getting locked out of different tables and pages and records and lions and tigers and bears. Oh my. So even though it's partially available, not really. It's very rare that you can still access that database. We typically have to wait until the undo phase happens. This is the huge pain point. This is the reason ADR was created. All those other benefits were just side benefits. This undo phase was the main reason for accelerated database recovery. The undo phase is where I have to roll back all the transactions in the transaction logs that were not committed at the point of time of failure. How far back do I have to go? All the way back to the oldest uncommitted transaction. Within the transaction log, wherever the minimally logged or minimal log logical sequence number is, which basically is the beginning of the oldest active transaction, which means that's that. If I'm recovering and I had a transaction that was running for 2 hours or 3 hours or 10 hours, I have to roll back. And if it didn't commit when the power went out or when I was recovering, I have to roll back all the way back. How long is that going to take? About as long as it did to go this way. So if it took 3 hours to go this way, it's 3 hours to come back. We're just talking about driving to an hour and a half to a customer and then an hour and a half back. So it's 3 hours of driving. Same thing here, my transaction log. If my transaction, my oldest active transaction, now I could have 10,000 transactions in between that only took seconds, I still have to roll those back, but it's only going to take a few seconds to roll those back. The huge pain point is, what is the oldest active transaction? I have to roll that all the way back. So I only as fast as my weakest link, in this case, that oldest active transaction. That's the huge pain point that we're fighting, or the main reason we have ADR. Once that happens, then my database is fully available. Everybody's happy, yay. But then my boss comes in and says, John, why did it take 3 hours to recover the database? I don't know. Someone had a long-running transaction. So that's our current database process. The implications, as I just kind of mentioned, if I click on the right slide, click on the slide over here. Common implications are the issues, the pain points we run into. Recovery time is roughly proportional to your longest running transaction. Rolling back large batch operations, such as a bulk insert, if I was inserting 10 million records, and I have to roll that back, takes a long time. And my transaction log might run out of space. This is another issue that people run into. If I'm inserting 10 million records and I didn't change my recovery model to bulk logged, I always said bulk import, bulk logged, it's possible my transaction log runs out of space if I don't size it correctly, or it just gets huge. I know people who have great big large drives just to store their transaction log because they have those long running transactions. Not anymore, because of our accelerated database recovery, we can use less drive space for our transaction logs. We can use that same space for our persistent version store. So one of the downsides to ADR is the space it takes for the persistent version store. I'm getting that space from the size of the transaction log. It's kind of balancing. Plus, the persistent version store cleans up after itself, as we'll see in just a moment. So it's not really that big of an issue. That one downside to ADR. So I always praise ADR, like, oh, this is awesome. People always ask me, what's the downsides? There are two downsides that I can think of. One, extra space for the persistent version store, which actually takes care of itself. The second one is your update statements take longer. But the trade-off, having your update statements take, what's the 18% longer? The benefits far outweigh longer running update transactions, as we will see. Okay, what are our 4 core components? These are, now we're getting into ADR. So I'll show you the process with ADR. I'm going to talk about the 4 components that are added to the recovery model that's used to maintain all this, to maintain everything. I'm going through the components first, so as we go through the process, we'll definitely understand what's going on in the background. The big one, persistent version store. The PVS is the main component. It's actually storing all my row versioning of my records. So it persists row versions in the database, itself rather than tempdb. So I mentioned this one, side benefits. It's now offloading snapshot isolation, offloading row versioning to the PVS. And I just thought of a question in the back of my head. I just heard Sam's voice in the back of my head talking about recommitted snapshot isolation, and I don't know the answer. We're gonna have to look that one up. I just had a question in my head. Okay, so persistent row versions in the database offloads that contention, as I mentioned. But the versions work just like row versioning in the tempdb. If you worked with the tempdb and row versioning and snapshot isolation, the PVS works exactly the same, except it's in the actual user database. And the versions will have the previous state of the data and a transaction ID of the version of that record. So as people are working, we can actually, we'll have the row, and then what's the previous version of that row. So you can kind of think of that. I don't know if you've worked with OneDrive or stored files and you want to restore to a previous version of the file. That's kind of what this is doing. I just want to possibly restore to a previous version of that row if there's a problem. So that fast undo process happens because when I recover, I don't have to roll back the transaction anymore. I don't have to read that transaction log sequentially backwards. I don't have to read all the way back to that oldest active transaction. All I have to do is go back to the previous version of that row. And I say, here's the row we had at the point of time of failure. Just go back to this previous row. We didn't finish this row. Go back to the previous one and mark this one as terminated. Is now terminated. The term actually marks it as aborted. It marks it as aborted that this is the bad row. Go back to the previous row. And that can happen in a matter of milliseconds. Just go back to the previous row. So it happens really, really fast. My next component is the logical revert. This is the process that keeps track of all the aborted transactions. It's an asynchronous, I don't know why I keep looking over there. I'll look over here. Asynchronous process that performs row level version based undo. So the persistent version store is what's storing the row versioning. The logical revert is what's actually doing the undo. Like, let's go back. Let's logically revert back to the previous version. So it keeps track of all the aborted transactions, performs a rollback using the most recent committed transactions from the persistent version store, and immediately releases all the locks. Release the locks once I roll back. So I immediately, once I roll back to the previous version, I release all the locks. Everybody's back ready to access the database. We haven't done any undos or anything like that. My database is ready to be connected, not partially like we did previously, where after we did the redo, then we had to partially accessible, but I still had locks on all the tables, and I still had to wait till the undo process happened. Once the logical reverts back to the previous version, it immediately releases the lock on that row, because I no longer need access to that previous or to the aborted record. Everyone can access the previous version of that record. That's the magic. All right. The other part of the magic, I should scratch my head real quick. The other part of the magic, all my non-versioned operations. The persistent version store is only going to keep track of really basically modifications to your records, or modifications to objects, I should say. That's a better term. But there's a lot of non-versioned operations that happen where there's like bulk operations where I'm not actually keeping track of individual rows. I'm just saying we updated these extents, or lock acquisitions. I no longer have to really keep track of, well, I do need to keep track of lock acquisitions, but I don't need to keep those in the transaction log anymore. All I want to keep track of is, all I really need to keep track of is what row am I working on? The only thing I need to do in my transaction log is what have I done since the last checkpoint? So any of my non-versioned operations are going to be stored in my special log. I call it my special log. It's actually the secondary log. It's an in-memory log stream, in-memory streaming log that keeps track of all your non-versioned operations. This is useful so after the logical revert, is it after or before? Actually, before the logical revert, I look into memory and say, okay, what was happening? What was all my non-versioned operations? Just undo those non-versioned operations. We don't need them anymore. Now, it is in memory, but it occasionally persists what's actually happening in memory to disk. So in case I need to recover, I could just read what was the what was my non-version operations. So that also keeps my transaction log small because I don't need to keep this information in the transaction log anymore. Excuse me. And since it's not the non-version operations are typically very, very small anyway. So it's not taking up that much room. Where 2 bytes for I just took a lock. So there's 2 bytes. So it's taking up that much room. So it's not that much. Now my favorite component is the cleaner. Bring in the cleaner. And the cleaner cleans up after myself, or cleans up the PVS, cleans up the persistent version store. I mentioned that there has to be a downside to this, right? There has to be a downside to ADR. I mentioned the two that I can think of is that the persistent version store is taking up space, which you're kind of balancing that from how much space you were using from the transaction log previously. And you have all your row versioning and stuff, so it's going to take more room. The cleaner, though, you have a special asynchronous process that goes through and cleans up your row versions. How fast? It happens so fast that sometimes I can't get in the demo. I can't get to the cleaner before the cleaner has cleaned up my persistent version store after I've rolled back an operation. I have to make sure I do that part of the demonstration fast enough that I can get to the cleaner before, so I can show what it looks like before and after the cleaner happens. Typically within 5 seconds of a rollback, the cleaner goes through and gets rid of all those aborted transactions. Anything that you don't need it anymore, we're getting rid of it. We're taking it to the Goodwill. You don't need those records, which also makes my transaction log small, makes my persistent version store small. It cleans up after itself. I don't have to truncate log, reduces a lot of log management. I don't really have to, I should monitor my PVS, which I'll show you the command to do that. But the cleaner it cleans up after itself. Very, very efficient process. Okay. So now that we know those components, let's look at the new process. We're going to look at the new process. We'll look at some comparison times and then some frequently asked questions from the many, many times I've delivered this since SQL Server 2019 came out. The questions I would typically get in the session, and then demo time. So that's why we have 3 slides here. Should take about a few more minutes here. Then we'll get into the demonstration, which I know you will love. So phase 1, still the same. I'm still going to analyze everything since the checkpoint, the oldest dirty page. That's still the same. I do add one little piece to this, though, to the analyze. I add that I reconstruct what was in the secondary or streaming log, all my non-versioned operations. Any non-versioned operations that are persisted to disk as part of the checkpoint, I just reconstruct those and say, okay, we need to add these non-versioned operations. Still a couple milliseconds. The redo phase is actually broken up into 2 parts. So before it was just one phase. If you read the documentation, docs.microsoft.com, you can Google search ADR, docs.microsoft.com. If you, they actually say phase 1, phase 2, but we already got one phase. So I renamed them phase 2A and phase 2B because there's still that second phase. Phase 2A will redo from that S log. So all my I misspoke here a second ago. Phase 1 reconstructs the S log. It's phase 2A that actually replays or the non-version operations since the oldest uncommit transaction. All those non-version operations from the S log that's been persisted to disk are rolled forward. So I'm just reading all those non-version operations that were on disk before the last checkpoint. Then I just need to read the transaction log since the last checkpoint to replay anything there. Anything that, excuse me, anything that was happening since the last checkpoint. And as soon as I'm there, locks are released. Database is fully accessible. Where previously at this phase, I still partial locks all over the place on different tables. I can now access the database, all my users. So to my end users, it's less than a millisecond that I recovered. Now I still need to go through the undo phase. The undo phase, which was my pain point, where I had to go all the way back to the oldest uncommitted transaction. Now I just need to go back to the oldest checkpoint. So we're to not the oldest, but the last checkpoint. I don't need to go all the way back. Anything prior to the checkpoint is any non-versioned operations that was in the S log. I'm going to undo from the S log that's in memory. Everything that was versioned, I just need to roll back since the last checkpoint, because anything before that, before the last checkpoint, the logical revert is already reverted back to the previous version. So since it never committed, I don't need that version that didn't commit. So the logical revert just rolls me back based off what is the previous version in the PVS store. I'm back up and running. Now I always get the question, I always get the question, does it really speed up the process? I said, sure, I'm going to test 200 million times on my poor little laptop here to give you some numbers. I'm not. I didn't. I'm going to put this in the chat box real quick once I find my link. If you would like to go more detail, there is a white paper that was created called Constant Time Recovery. I think the main author was the Antonopoulos. I know I messed up his name. There's a link there that pulls up a white paper. Here's a white paper. I sure had it. Verifying the link. Comes up, and you can read it. It's about 12 pages that goes through everything I've just talked about. But they did go through, and actually ADR was originally called Constant Time Recovery. A little history for you. But these fine people here are the people that worked on accelerated database recovery. You can read the white paper. I've read it several times. It's very exciting. But you can go through it and go through all the processes. You can see the analysis and redo to go even more detail, database recovery process. But they actually, if I scroll way down, way, where are you at? There you go. I stole these pictures that's on my slide directly from this white paper. So I wanted to make sure that you had that documentation. While I'm here, I'll also give you the link to docs.microsoft.com. That's in the chat box now to read more on ADR. Okay. But those fine people did the testing, and you can see before CTR, or accelerated database recovery, that insert, updates, delete, what are the different phases? The analysis phase, hardly anything. My redo phase, a couple hundreds to a couple thousand seconds. Undo phase took a long time. Excuse me. Now, the right-hand side is with ADR, accelerated database recovery or constant time recovery. This slide is also an example of bad data visualization. If you take a Power BI class or data visualization class, this is an example of bad visualization because it looks like it's very comparable between the times. But, excuse me, this axis, the time in seconds, is in the hundreds and thousands. This is in this 15 seconds. I think the maximum here, if I deleted 10 million rows, it took 15 seconds. So this entire chart fits to like right here, right here. So bad visualization, bad data visualization there. But 15 seconds as opposed to what's the slowest thing there? Maybe a minute, 2 minutes. But some of these others like 2,000 seconds, 3,000 seconds. So very fast. The last thing before the demonstration, the questions we always get, will my database be larger? Will affect performance? Here's the downside. Here's the rub. Here are the issues with accelerated database recovery. Will my database be larger? Yes. You will need to monitor to determine the difference. You can check that white paper or read the white paper for more details. But remember, you're trading off for that persistent version store. You're trading off the space you would have used for your transaction log. You're offloading space from your temp DB. You're reducing contention, and you can see how much more room am you using. According to that white paper, 50 million modifications adds 1 gig to your database. Personally, that trade-off is worth it. If I'm going to add 1 gig for 50 million for every 50 million modifications to be able to recover in a millisecond, worth it. Will it affect performance? It depends. Your write-heavy, insert, update, deletes are the most susceptible. Select operations, if you're just reading, won't affect your performance hardly at all. But again, according to that white paper, the biggest hit is going to be for your updates. It's going to take longer to update your row versions, about 13%, 13.8% utilization. For your other workloads, insert, update, deletes, it adds about 2.5%. So if you have a lot of update heavy, then that's the huge downside to ADR. But look at all those other things you get. all that other, you're saving hours. Can you add a minute, a minute to a query or 30 seconds to a query, or to an update? Again, the balance, it depends. In my opinion, the time you save, the space you save, the headaches, the troubleshooting you save far outweighs, or the benefits far outweighs this inconvenience here. How is PBS different than the version store? Basically the same. It just offloads anything you're doing to the TempDB to ADR. How does it affect availability groups? PBS and log records still replicate to the secondaries, and secondaries communicate the oldest versions needed to the primary so it can do the undo. But it will also speed up the undo phase on your secondaries as well if it needs to undo. Plus your logs, your transaction logs are going to be much, much smaller now. Okay. So let me get into my demonstration time. Go ahead and close my slides out. We'll come back to the questions. But let me get into my demonstration. Open up my SQL Server. This should take shouldn't be too bad. So here I am in my SQL Server. And again, my demonstration code is on my GitHub, SQLMCT, github.com/SQLMCT. Switch over. I'm going to create a brand new database just for us called ADR Demo. So I create that database. Then I'm going to create a file group. I could have created the file group with the database. I just wanted to highlight that I'm creating a file group with a secondary file so I can store my persistent version store into a separate file group. Now I know someone's probably saying, John, you're just putting it into the same folder. I only have a D drive. I only have the C drive and a D drive. So in the real world, you would put it onto a different drive to get the full benefits. But the limitations of my laptop. I am going to create a file group to store a persistent version store. So I'll execute. And I'm going to change my compatibility level to pre-2019. Wait a minute, what? Yes. Another side benefit I didn't even mention. I'm setting this up in 2019, but the database can be pre-2019. And I can still have ADR. I have to run it on a 2019. So my database, I can have older versions, older compatibility level, or older versions. I think that's 2017 version I'm switching it to. Now I'm going to check my sys databases. There's a new column that there's my compatibility level and ADR is currently off. So that's what we're going to do. Okay. Next thing, I'm going to create a table with 750,000 rows. I'm inserting rows just so we can have data to play with. Well, that went pretty quick, 3 seconds. So I just inserted an identity field and then random numbers with the words JD insert. I'm going to create a non-clustered index just to speed up my reads. Doesn't have anything to do with ADR, just to speed up when I select data, because there's 750,000 rows. And I don't have time to do performance tuning. Well, I just did performance tuning. I added a non-clustered index. And now I'm going to select. I'm going to look at the data. Look at it now. So I'll execute. And we have 750,000 rows, account ID, the account code, just a random number, JD insert, and there's the time and date. 750,000 rows. Took, what was it? 9 seconds. Took 9 seconds to run. So now, again, this is without accelerated database recovery. I'm going to begin a transaction and then delete all those rows I just inserted. That's just crazy. But I'm going to delete those. Notice I do not have a commit. Notice we go to get it started because it's going to take about 30 seconds. I'll get this started. There's no commit because I'm starting the transaction, which places the lock on the ADR test. It's going to be at the table level. It's going to escalate to a lock at the table level. But it's going to delete those 750,000 records. It takes a little bit. I think it takes about close to 30 seconds, maybe 27 seconds. We'll see here in a second or in a moment when I delete those records. Hey, Joyce came back. Welcome back, Joyce. Well, maybe. Okay. So it took, CPU time took about 8.5 seconds. But the elapsed time, having to go through and looping through the runnable queue and everything like that, took about 31 seconds, the elapsed time. Hey, Mike. Welcome back, Mike. Actually, Mike wasn't here earlier. Maybe. I don't know. So actually, I just want to copy this part, CPU time. And I'm going to copy that down to line 102 so we can compare it later. I'm going to put that right there so we can compare the differences on deleting records. Okay. So I'm going to look at the table, and we can see the records are gone. So I inserted them just so I could delete them. Okay. Now let's look at our transaction log. Again, this is our current process without accelerated database recovery. So if I look before the checkpoint, what's the size of my transaction log? And run the checkpoint, what's the space after? Execute. Before and after, the space is about the same. And I'm using about 95%, which is about the same. It's just after has an entry there for my checkpoint. I just ran a checkpoint. So I got the 3 entries there that I did a checkpoint. But it's basically the same, 741. I'm going to write that down. Actually, was it 740? Space used is 741. So if I go down, so I'm going to put that there. So it's currently 741 megabyte before ADR. There you go. Transaction log is 741 megs because it still has to keep track of. Let me go back up here. When I did that checkpoint, let's look at our results. I just did a checkpoint. It still has to, since I'm not committed, I did the begin, I'm not committed. I'm checking the transaction log. It still has to keep track of that transaction all the way back to the beginning of deleting 750,000 rows. It's going to keep track of that until either I roll back or commit. So my size of my transaction log has to keep track of that. That's pretty big just for that single transaction. Okay. Now I'm going to roll back. This should take, it's about half the time rolling back deletes. It's going to be about half the time that it took, was it 31 seconds to delete? And I think it takes about 15 seconds, 16 seconds to roll back. There's about half the time or almost as long as that duration. A duration of my oldest active transaction from when I deleted. It's at 23. It's about the same. Okay. So 24 seconds to roll back. But it's not that bad. But remember, it's only 750,000 rows, and I have nothing else in this database. Oh, Sam's leaving us. So, thanks. Oh, if you run the code, wait till you get the rollback. Because this is how long it took. This is how long it took without ADR. This is how long it's going to take with ADR to do the rollback. That we'll get here in a little bit. But thank you, Sam. Okay. So if I roll back up, I just pasted that there. Let's check to see I did the rollback and it's back. The records are back. Okay. Now I'm going to turn accelerated database recovery on. I'm going to store that persistent version store into its own file group. Oh, I got to wait till I finish selecting. I'm going to scratch my eye. Check the compatibility level. Is it on? Or sorry, accelerated database recovery is now on. And here's a new dynamic management view, persistent version store. So I can see the size of my persistent version store. Again, you could borrow my code from my GitHub. Currently, the size is 0. There's no aborted transactions because I've not done anything with ADR yet. I just turned it on. Now I'm going to delete those records. I'm going to delete those records. Begin the transactions and delete. This should take 30 seconds. Hey, Joyce is back. Welcome back, Joyce. Joyce is back. Back again. Joyce is back. Joyce is back. Joyce is back. Na 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 na. All right, so finished. It's still running. Is it finished yet? Okay, there we go. So rolling. This is I was deleting the records. that really don't really need to see this time, but it's about the same with or without. It's a little bit more CPU time, but a less lapse time. So the effect that I have on my a delete or an insert is very little. Now I do have the code for update. We'll see it actually takes longer to for update statements, which I'll save that code for you if you ever want to do that. You can practice that. It's in my demonstration code down on like line 50 and below. But you can see the actual operation, it's actually a little bit faster. Okay. Now, but let's check our transaction log. Remember, previously it was 741 meg before and after the checkpoint. This is my transaction log. I execute. Now that I don't have to keep track of that long-running transaction, before the checkpoint, it's 330. That's half of what I was using. My transaction log is the size of a half before the checkpoint. I only had to keep track of everything that happened since the checkpoint. After the checkpoint, 201 meg, because I only needed to keep track of, again, anything since the last checkpoint. The only thing there is basically your non-version operations. And I'm only using 25% of it. So automatically, I'm aggressively truncating the transaction log. If I look at the persistent version store, I am using about 82 meg there. So that's the kind of the trade-off. I have 82 meg in the persistent version store to keep track of the previous versions. All right, here's the magic hands. I'm going to roll back. I'm stalling because I'm going to roll back this transaction. Previously, it took 25 seconds to roll back. It's now going to take, boom, 1 millisecond. That is ADR. That is the main reason to have ADR. I just took my recovery process. Actually, this time it was 1 millisecond from 25, and that's just 750,000 rows that I rolled back to or reverted. If I select, I can see the rows are back. 750,000 rows are back, rolled back in 1 millisecond. Again, all the downsides, that's a huge trade-off. And that's one transaction, 750,000 rows, imagine. Now, if I check my PVS, as I was talking about, I have to make sure I get to it quickly. It's still 82 meg, but now it's showing I have one aborted transaction. I rolled back one transaction. Let's check my transaction log now, the size. Before and after, remember it was 741 without ADR. With ADR, before and after, before I did the rollback, it was 360, and it was 201 after the checkpoint. But after I do the rollback, 24 meg. So I'm saving, look at all that space I'm saving on my transaction log, which is about the amount of space. Well, my PVS is 82 meg. My transaction log was taking up 741 meg. So I'm saving 700 meg already and using 82 meg for the PVS. So I'm saving space by using ADR. Yes, my database is larger. My transaction log is much, much smaller. And remember, while I was talking there, the cleaner is going to come through now and removed all those stale rows. So that version store database, I said it was 82 meg, is now 0.07 meg. And it removed all those aborted transactions. So when I said my trade-off was the size of that PVS, the cleaner comes through and kind of resolves that issue by itself. Hey, John, what about updates? So the rest of if you want to play around with the rest of the code, if you want to walk through doing the exact same thing, I've set it up where you can test updates as well. This is the other downside to ADR, as opposed to the space the PVS uses, which we just saw really isn't that big of an issue because it cleans up after itself. My updates are going to take longer to run. We saw with the delete is about even, about the same amount. But with an update, it is going to take longer. I do have the code there. If you want to play around with it, you're more than welcome to download it. Just kind of walk through and see to see what's the time limit on the updates. But other than that, excuse me, that is ADR. That's accelerated database recovery. If That's it. That's all I got. That's accelerated database recovery. So if you have questions, I'm here for questions. Other than that, thank you for coming. Drive safely. Tip your waitress. I was promised pizza. I didn't get any pizza. Ross, I turn it back over to you if no one has any questions. If Ross is out there.
Yeah, I'm out here. I had a little trouble enabling my mic for some reason.
That happens.
So, it seems to me I'm going to editorialize.
Go ahead.
It seems to me that this would be a feature that you'd want to have enabled by default.
It is on by default with the Azure products. That's how much Microsoft thinks about it. All the Azure. It's not on by default because people are scared of new things, but maybe in the future.
Well, the Ross Reed isn't scared of it. Ross Reed's very impressed. And so I think I'm going to be going and I just started moving stuff over to SQL Server 2019, and I didn't think about enabling this, but this is very impressive.
I definitely test first, obviously.
Well, yeah.
Yeah. To see if it's right. Ask your doctor if ADR is right for you.
Well, it's like the food. It's not if it tastes good, it's not right for me.
It's not right for me. There you go.
Yeah, but yeah, the yeah, I'm going to do that. I'm gonna set this up and test this out.
I could be lying to you.
I don't think so. You look pretty honest to me.
Yeah. It's because of the clock in the back. Oh, I turned off my camera anyway.
Yeah.
All right. Well, that's it for me. Unless you all had something more. Everybody was quiet the entire time.
Yeah, they you had them all spellbound.
Yeah. Snowblind, snowblind, snowblind. Was that Sticks? Might have been Sticks. Thanks, Porfirio.
Yeah, and thanks for presenting,
man.
John. Really appreciate this.
No problem. I enjoy teaching. That's what I do. I think Sam's still here. He said great session, but he didn't actually leave.
Yeah, it looks like he's still here.
He's stalking.
So
He said
yeah,
he said he's going to leave after 20 minutes. He stayed 50.
but yeah, I'll have this recording posted on our website, and
Cool.
we actually have a YouTube channel where we upload our recordings, and then I'll post that link onto our website. Next month we're not going to have a meeting. I was supposed to speak, but I was struck down with COVID, and well, I just didn't get it finished. So we're going to take July off, and we'll be back in August, where I'll be speaking and going to talk about DBA tools.
Oh, that's a good one.
Oh
The book
yeah,
just came out. I think the month of DBA tools and a month of lunches came out yesterday or tomorrow. It's either yesterday or tomorrow's coming out.
And I placed my order for the printed version after Frank Gill had placed his order for the printed version, and I told him how Captain Kirk of him. And then I don't know, several people chimed in, and so I thought, well, I bought the printed version as well.
Yeah.
So I tweeted that, and I said Kirk out.
Kirk out. I'm thinking about it.
Yeah, it,
All right.
I've been using it to do migrations from SQL Server 2016 to 2019, and it's it's amazing. I mean, I got this one server that's got a boatload of databases on it, and with one command, I get them all. I get all these databases migrated. So it'll come in real handy for
Oh
SharePoint.
yeah, yeah, absolutely.
But yeah, it, so anyway, that's what you have to look forward to in August.
All
So
right. Well, I'm going
well,
to take
thank
off.
you, John, and it was great session. Great
I think
session.
I appreciate it. I'll see y'all later.
All right, thanks. Bye now.